All right, solving word problems. This can be a little bit tricky as word problems, or what we may consider to be contextual problems. I should maybe put that in there. Contextual problems tend to be a little bit of a challenge to find and to determine what pieces of information are valid and which pieces of information are not needed quite as much. So the ones that are in fact valid, we're going to be able to kind of find that, and we're going to have to determine what we need to use and what we don't need to use. A word problem can often be written as an equation. Now the ones that we're going to look at this year in class are going to all be linear functions, so they're going to be straight lines. Next year, when you move into grade 11 applied math, you're going to start taking a look at inequalities as well as quadratics, which are a lot of fun. At least I find a lot of fun. And then when you get to grade 12, you get to deal with all sorts of cool little functions, and you have to kind of figure out which function represents which one. Most of the time it's given to you fairly straightforward, but it sometimes is a matter of trying to figure out which equation you're going to end up using. But remember, this time we're only dealing with linear functions, so it's just straight lines that we have. So what we're going to do is we're going to choose one variable for the horizontal axis. So that's going to be our independent variable, and the other for our dependent or our vertical axis, which is our dependent variable. Okay, and we're going to want to make sure we define these variables. Okay, what is x, what is y going to be, and we'll go through that a little bit as to what we, which one is which. Next thing we do is we determine the slope, okay, between 2 points if the slope is not given. Okay, so I'm going to either give you the slope and 1 point, or I'm going to give you 2 points, and then you're going to have to find the slope and then put it into an equation. And then the next thing that we're going to do is we're going to enter the values into our formula/form. And remember that if we don't know the y-intercept, we're going to use y is equal to mx. We can use, y is equal to mx plus b, but for this one right here, we're going to use slope point form, x minus x1. Okay, so we can use either one depending on if we're given the y-intercept or if we're not given the y-intercept. All right, so that's what we need to do. Now let's take a look at an example. So a temperature, okay, in degrees Celsius is linear function of the temperature in degrees Fahrenheit. Okay, the boiling point of water is this right here, so these two are equal. So 100 degrees Celsius is the same as 212 degrees Fahrenheit, and the freezing point of water is 0 degrees Celsius and 32 degrees Fahrenheit. So those are also exactly the same. So we have our 2 points. Okay, we have these two that are together, and we have these two that are together. Now the first thing that we're going to do is we're going to define what is our x and what is our y. Okay, now you can choose whichever one you want because these ones aren't really dependent or independent on each other. And so x is going to be the temperature in degrees Celsius, and y is going to be the temperature in degrees Fahrenheit. Okay, so that's what I'm going to do. And so that means that the 2 points that we have, Celsius will be x and this will be y. So it'll be 100 to 12 is 1 point that we have, and the other one here is 0.32. Okay, so those are 2 points that we have, and these 2 points are going to help us to come up with our with the values that we have. So first thing we do, we need to find the slope. Our slope is rise over run. Okay, and we don't have a graph, and these ones are quite a ways apart, so we're going to have to use our y2 minus y1, our slope formula, x2 minus x1. And we'll call this right here, this will be x1 and y1, and this will be x2 and y2. And I'm doing that because this one comes after or comes to the right, so we're going to move from left to right. Now again, it doesn't matter, you can do it either way. If we plug this in here, we're going to have 212 minus 32 over 100 minus 0. This is 180 over 100, and this simplifies down to 9 over 5. Okay, so this right here is our slope. Now I did that very quickly, but again, slope should be able to be found quite quickly. Sorry, that was a little bit faded out there. That should be a little bit better. Slope should be able to be found very quickly. Again, we've gone through this in the past. You can either graph it out or you can use your slope equation to find that. Now, we have two different equations that we could use. We could use x1 and y1, or we could use x2 and y2. If I use the first one here, so if I use this one here, I'm going to have y minus 32 is equal to my slope, x minus 0. If I use the second one, I'm going to have y minus 212 is equal to the slope, x minus 100. Okay, there's our two equations. They're in fact the exact same equation. It's just written out slightly differently, and it's going to come up with the exact same values no matter which ones we use. Okay, so that's how we come up with our equation for that graph. Now, what you may have noticed, and some of you might have seen this here, is that this is in fact our y-intercept. So we could actually have written out as y is equal to 9 over 5x plus 32. Okay, that's another way that we can write it out. And if we were to put either one of these into graphic form, we would get this right here. Okay, we would be able to solve for that right there, and that would in fact be the correct answer. Now, part B is going to actually ask us to come up with a value, and if it says that iron melts at 2,795 degrees Fahrenheit, what is that temperature in degrees Celsius? Okay, so how hot would this be in degrees Celsius? Well, we can use any one of these three. I'm going to use this one right here, just to kind of, again, show exactly how we mix things around. X minus 100. Now we're given a temperature in degrees Fahrenheit. Remember, degrees Fahrenheit is our y value. So we're told that y is equal to 2795. Okay, that's what we're told. We're going to plug that into our equation. Let's try to get a different color. So 2795 minus 212 is equal to 9 over 5 x minus 100. Okay, solve what we can. Here we can subtract these already. So 2795 minus 212 is 2583, and that is equal to 9 over 5 x minus 100. Okay. Oh, there we go, sorry, move that up a little bit. So we're left with this here, and we're trying to figure out what is x, what is our temperature in degrees Celsius. Okay. To do that, we first need to try to get rid of kind of some of the things that are multiplying into the brackets. Okay, we could multiply through the brackets if we wanted to, and then we would subtract. Or this right here, instead of multiplying through the brackets, let's just get rid of it by dividing by 9 over 5. And so we're going to divide this side by 9 over 5. Now you can always do 9 divided by 5, and that gives you a decimal of 1.8. So you could divide by that, or you can do 2583 divided by 9 over 5. And this gives us a value of 1435 is equal to x minus 100. Okay, so what we did there is we got rid of the 9 over 5. Those cancel out, and that's what this side became. All right, final step, get x by itself. We need to add 100 to both sides. So 1535 is equal to x. Okay, that was okay, very quick. That cancels out, and we get that right there. So we can say that iron will melt at a temperature of 1,535 degrees Celsius. Okay, and that's how we can solve it using the equation that we have, that we're given, or that we found.